Good afternoon, everybody. Welcome to the final day of the Advanced Topics webinar that we have planned for this week. There were some questions earlier in the week about structures that we went over. I believe it was on day 2, and that was all flow and hydrodynamic related. But there were some questions about, are there ways to affect structures with the CMS-Wave model, and then have that interaction between the flow and wave in the times when we need it. And so the answer to that is yes, there are, and I will go over a few of these just right now. So bear with me, I only put these together late yesterday afternoon, and these are based on some slides from a few years back. To the best of my knowledge, there is no CHETN or technical report on the structures with the CMS-Wave. They are included with the overall model itself and the tech report, but nothing really on the guidance or using it within any version of the surface water modeling system that I know of. So just to cover a few things, I did want to go through, since I've not used this in several years with the SMS, I wanted to make sure that it was working with the newest version of SMS 13.0. I'm using 13.0.9. I did see in some of these tests when I was setting up the CMS-Wave grid with the spectral energy that the model did crash a couple times, not the model, but the interface crashed. And so you might take that into consideration as you're working with this. We are going to be working on improving this. The CMS-Wave model itself will be migrated from its static form as far as the dialogues into a more dynamic interface over the next year. And so there may be some changes coming up, and if that happens, then we will record a new video or present a new webinar on that. So anyway, to get started, I have the SMS 1309 open, and basically what you do is you load a grid, and for this case I created a simple grid with evenly spaced cells, and just so I can demonstrate the functionality of these structures within CMS-Wave. So I've created a grid, and I have created spectral energy to force that grid with. And so what we need to do is to come into the grid, select a few cells, and then right-click. You have the option for cell attributes, which brings up another dialog. That dialog, you can select structure, and then change the type of that structure to one of several different options. And there are more options than I really know how to use. And so hopefully there will be some guidance in the near future on these different options and how to use those. But I'm going to go over just one or two of those, and then I will also show this in a demo later on. So for each one of these types, there's an option to use some sort of a modification value on that type, and then to supply that value. So this could be anywhere from a bathymetry modification, change from what the default is in the grid, or it could be an elevation of a floating breakwater, or the draft of a some kind of other structure. It just depends on which option you choose. And so we'll go through and show that. But once you have these cells selected and you make the choice, assign the modification value, you would click OK, file save, export, and launch. And then you're ready to go and see what the results will be. And so I'll show that later in the demo. However, I've got a couple more slides that kind of show actually four different scenarios. So the first one of these is just an idealized example, island example. And so the option that you would choose among those in SMS is the non-computational cell. And so for this case, basically I've selected 20 cells towards the middle of the grid and turned off them from being computed within the wave model. And so when the waves approach and get to that cell, they act like they are land, regardless of the value that you have specified as their depth value. And so you might see a little bit of steepening of the waves, and then a break, and then a change. You see there's no wave energy among those cells whatsoever, and then behind this area you do see a reduction in wave energy, as you would anticipate. In that particular case, just to go over it, I have the 20 feature cells. I am modeling only one wave. That wave I'm keeping consistent for the next, for these 4 examples. But basically it is a 2-meter wave with 6-second period, 30-second degree direction, and then using a gamma of 4. I did, for the model control, I did turn on backward reflection, and I'm using a value of 0.05 coefficient. I did turn on Manning's coefficient, constant value of 0.025 as well. And one other file that is changed when you assign these structures is the .struct file, and basically the information that's contained in it is very simple. It has a number of cells that are to be included in a structure, and then the ij of those cells, along with some value and a parameter beside it if needed. The first or the third column is always the structure type, and then the fourth column would be the modification value that you would assign. So anyway, this was, it's a pretty simple to do these, each one of these. The next option that I'm showing is an idealized floating breakwater. There is an option for floating breakwater in the list within the SMS, and so I chose that particular value, and that has a modification option for draft, and so I turned that on and I inserted a 2-meter draft. So in this case, when the files get written out, the structures have the same 20 cells, the I and J's are the same, however the third column is now all type 3, and then the modification value is all 2. And you see that in relation to the last example, you do see some wave energy affecting these structure cells, not a lot, but it's very small, but there is some, and you see a change accordingly around the grid as those waves progress. For the next option, we are doing an idealized platform, and the option that's best suited for this among the list is wall breakwater. It's not the best terminology, however, it does what we want this to do. So I select wall breakwater for these cells, and then I'm giving an option to change the modification value, and it shows an elevation. And so that elevation is different direction than depth is, of course. Depth for our models is positive down. Elevation, you have to anticipate that that is positive up from the water surface, and so in this case we specify a value of 1 meter, and it's relative to our overall datum, which is mean water level. So we have those cells selected. You see the structure type is now changed to a 4, and the modification value is set to 1. You see the 20 cells. It's a lot more energy coming underneath this platform, but not a whole lot. I mean, from the last one, you see quite a bit more energy, close to, between 0.6 and 0.9 meters, it looks like, of wave height. And so the values around it are adjusted accordingly. The final option that I'm showing is a submerged platform. So it's the same structure type, so it's still that wall breakwater. However, this time for the platform elevation, we're specifying -2 meters. Okay, so we have a platform elevation of -2 meters, so that's 2 meters below the surface of the water, and you see from this there's not as much reduction of energy. If not, there's a little steepening that is occurring over top the platform, and then on the back side you have the reduction as you would anticipate. So looking at the file, you do see that the structure type is the same, and then the value assigned for the elevation is now a -2. So that's pretty much it. It's very simple to select the cells, to assign the values, quickly save, export, launch, and run, and then you can quickly see the results. And so I'll show that in just a little bit in the demo. But I did want to say that if you have any questions or concerns about using these structures or anything else, anything to do with CMS-Wave, please contact Liwa Lin, and here is the email address for him. If you have trouble getting up with him, please contact me. A few publications that might give a little bit more information about the overall model itself, because like I said, there is no direct publication for structures.